Thank you very much for the very kind introduction, and thank you for inviting me to this meeting. It's a great honor and a great pleasure to be here in Edinburgh. I hope I pronounce it somehow correctly. I enjoyed the very British weather, or the more British weather on Saturday, and the kind of un-British weather yesterday and today. And my colleagues at home were jealous because I texted them, I'm now at the University of Edinburgh and the weather is perfect. And they said, well, you left the British weather at home. It's raining cats and dogs in Karlsruhe. So I come from Karlsruhe, which is in the southern part of Germany. And today I'm talking about the building up of the national research data infrastructure. It is about Föderation, at least in 3 different languages. But frankly spoken, this is my title, and blame it on me and my vacation time that I wasn't able to deliver it on time for the production of your papers. The National Research Data Infrastructure is a large-scale endeavor. And in my talk, I will first show you some numbers to give you an impression what kind of network are we. And then I would like to dig into a little bit into the past and show 2 of the drivers that led us and our society and science to the place where we are as of today. And those 2 drivers are also driving our initiative. Then I will go a little bit, I will show you how we established the whole infrastructure and what infrastructure means in our network. I will show you how we are constructed as an association, and I will highlight some very concrete, specific first results from our build-up phase. I called this the story so far, part 1, because it gives an overview of where we are standing right now. But my very final slide will give a glimpse on part 2 that is lying in front of us. And in fact, the future in front of us might be a very good time for collaboration. So I'm also here to learn, and I'm eager to learn what you are doing here, what are your next steps, and how we can maybe do things together in future. Because at the end of the day, research for me is borderless. And all the success that we really are able to achieve in science is something that we can achieve together. So therefore, we should look for opportunities to really do that. Let's get into the talk. Our vision is data as a shared resource, and in particular, data as a shared resource for excellent research organized by the scientific community in Germany. Well, we are a national funded project. Therefore, here comes this, national community. But we try to be as international as possible. And that was actually the link to today when Carol Goebel, I guess some of you might know her, was at our conference 3 weeks ago. And we talked about different initiatives. And I think she was also matchmaking and linking here to this stage. And this picture is from a conference which we started in 2023. It's the first conference on research data infrastructure, which we hosted in Karlsruhe. And for the first time, our network assembled in person, in presence. We started right into the pandemic and right into the lockdown. So we created this network with zillions of Zoom talks, and I knew all the people just like this. But this was the first time of gathering together. And this has then established into a conference, which we just recently had the 2nd edition. I will come back to that later. Now, I realized yesterday in the evening I should give you some numbers. So the funding terms under which we are operating is that we get up to 90 million euro per year for the duration from 2018 to 2028. Of course, we were in the very beginning, we're just not capable of spending the money. We have just reached the phase where we are more or less spending all the money that we can spend. So in total, it's not 900, but maybe 700 something billion euros, which we are spending over the period of 10 years. So what is in the network as of now? We have. I can only estimate we have more than 1,500 contributors. We do know it because we have a Rocket Chat instance where all the people are interacting, and we have more than 1,500 active accounts. And those are people, many of them are funded through the initiatives, but many also just contribute, because this is our key aim, bringing together different communities and creating a wave that is bigger than the pure funding of the project. And I think it is fair to say that we achieved that in the first instance. We have in our association 322 association members, It's a non-paid membership in our association, and those are all the universities, all the Helmholtzes, all the Leibniz institutes, and so on. Not all of them, but a lot of them, who are part of our association, and they contribute to our vision to have data as a shared good. Within our structure, we have so-called consortia, and I will have a picture showing the different kinds of consortia. It's kind of 26 projects, and they are targeting individual communities, but I will explain this a bit later. So basically what we aim to is to have a reach within whole science, and science applied for projects, and 26 of them have been funded. We also have one cross-cutting basic service consortium, and this is about services that are useful for all the different communities. I will give you some examples, and I've seen you're working on the same stuff. We also have so-called sections that deal with cross-cutting topics to prepare services in that area. Right now, we have a list of 650 active services, which we still need to understand better. This is just an Excel spreadsheet. So we have to develop that into a portfolio, which is then manageable, where you can make optimizations, but also strategic decisions. So it's really a grassrooted, a bottom-up initiative where everybody is putting in whatever is there. And now we try to organize and to sort out jointly what the future of this is. We have lots of meetings, of course, but meetings are not a means by itself, but rather we want to achieve something. And what we want to achieve is a lot of the goals that I just saw on John's slides. It's community, it's trust, it's building up a community for its own sake. Now, to understand why we are there, I want to jump back, and I want to start as early as this picture depicts the birth of Jesus Christ by Sandro Botticelli. What was so special having this research data in mind? So what happened there? Any idea? Yeah. Well, there was a census. They collected information from the society. And it is one of the first, maybe the first reported census that was conducted. So they collected data about their people. Of course, it was for military purposes, of course. However, it was a data collection. And nowadays, and here's just one example, we have a lot. We repeat this census. So our state is well informed about the structure of our society to be able to make better political decisions. In fact, if you know the German story, so the census in the 80s was really controversial because people didn't like that the state was gathering their own data. And the census in 2011 was just nicely done because the sample was stripped down to the very minimal size, and statisticians had a very clever model so that the very small sample size still allowed for judgments and making decisions for the whole country. And this, for me, is one very good example where data is collected with a clear purpose, which is then also contribute to political, but also scientific questions. Here's another example. So this one is a telescope, which was invented in 1608, reportedly. And this one is actually from one of the most famous guys, Galileo Galilei. He did not invent it, but he used these telescopes. And what did he do? Well, he was an astronomer, and he was interested in astronomy. Nowadays, of course, we have things like the Hubble Space Telescope, which allow us to do basically the same stuff, right? To see things that are very far away with a clear picture and then draw conclusions from that. And that is a picture for human mankind has always been interested in developing tools that support science and research. And we have been getting much better in this recently. And we have research infrastructures, and that is the key message of this one also. We have infrastructures whose whole purpose is to produce research data in very good quality and attached with metadata, reusable, and all the nice features. And we have more and more from that. One final example. I knew this from my chemistry lessons in school, the Rutherford scattering experiment. Maybe some of you will also know it. It was about shooting atoms through a very thin gold foil, I think it's called. And then some strange things happened because some of the atoms were spreading into different directions. Well, first of all, he realized a lot of things are going through, and that was the surprise. And then some things are going to different directions. So basically, the conclusion was matter in the smallest area consists of nothing, and that was kind of new because everything is so solid. But in the end, at the end of the day, on the atom level, as we know as of today, it's just nothing, 99%. And he found that out. And he conducted this experiment and he drew conclusions from that. So he was a researcher conducting his own experiments and then formulating hypotheses and drawing conclusions. And nowadays we build things like the Large Hadron Collider in CERN that do basically the same stuff, but with lots of energy and of course with a resolution that is much more high, that has been scaled up. But at the end of the day, again, the story is we build large infrastructures that collect data. And maybe this is the second biggest machine on the planet. Maybe. What do you think is the biggest machine on the planet that human has built? Biggest machine? We all are connected to it. The internet. Yeah. Certainly that is the biggest man-made machine. And I will come back to that example a bit later. So one of the findings that also the people from the so-called FAIR principles had was more and more research data more and more research results are achieved by reusing already existing data. And that the colleagues took as a good chance. So Mark Wilkinson and other colleagues, Carol also, they formulated the so-called FAIR principles. So who of you knows what the FAIR principles are? Okay, yeah, most of you. I will shortly introduce them a bit later. They wrote this paper, accessible here, and they created this idea that data should be fair. And that is the basic idea of NFDI. So this is the one driving force. More and more research data is available, and more research results are being achieved by reusing existing data. So please make all or most of the data fair. So in a nutshell, our vision is research data sets are fair. And fair here is the FAIR principles. And what I would like to add is 3 little words, but they make all the difference. For all and forever. So what does for all here mean? For all means, of course, according to the data access policies. So GDPR regulated data should not be put on the web, as we know. But if you have a scientific interest, you are allowed and very often also eligible to work with the data. So for all has a regime under which data can be accessed, but in principle to all who are eligible. Now forever is such a small word. What does it mean for data, digital data? And well, my example here comes from Alice in Wonderland. You might know this book. And Alice asked, well, how long is forever? And the simple answer of the White Rabbit is sometimes just 1 second. And for research data, this is also true. So sometimes it is enough for 1 second. But for many other purposes, maybe 10 years is a good time for keeping the data. And maybe sometimes forever literally is also a good interpretation of forever. So we have to find out as a community, what does forever for our data actually mean? And we can only jointly find this out. Now here's the second driving force. And of course it's about AI, right? Artificial intelligence. And here's the little stories. In 1957, Herbert Simon predicted that a computer will be world chess champion in less than 10 years. First prediction. Second prediction, John McCarthy proposed in 1958 to transform the complete knowledge of humankind in first-order logic. So are you aware or familiar with first-order logic? Well, something you learn in computer science courses. It's a formal language. It has many nice properties. I'm a logician by education, so I think it's a good idea. But well, in the 1950s, this was really a bold statement, right? To transform human mankind knowledge into that. Let's look how it evolved from there. Well, it took a bit longer, but it came. So 40 years after, in 1997, Deep Blue from a company called IBM becomes chess champion. And the story is very famous. There's a very nice movie about it. Of course, the acting champion wasn't amused, and the story behind is very nice. But at the end of the day, Kasparov was beaten by a machine, and it was a very clever machine. of course. But then the story went on. 14 years later, in 2011, IBM Watson, another machine, became Jeopardy champion. And that is a completely different game. Jeopardy is about question answering. So here, the system was capable of doing question answering on the level of a game show where really smart people usually compete against each other. And the winner was this machine. And that opened up a new field for applications in the AI area. And all of you will be remembering that in 2016, so only 5 years later, the Google DeepMind AlphaGo became Go champion. And that was by many considered to be such a complex game that no algorithm would be capable of becoming a Go champion. And there's also a nice movie about this. And as you all know, that happened. And also the acting champion wasn't amused by this actual fact. And from there, the story went on. You had the ChatGPT example. So tremendous advances we have seen during the last years. Now, at the same time, let's look at the second vision. John McCarthy proposed to encode the complete knowledge of human mankind into first-order logic. So what happened? Well, it took 32 years, and in 1990, Sir Tim Berners-Lee, British citizen, invented the World Wide Web. And I really recommend to read his paper. It's only 5 pages where he says, oh, wouldn't it be cool if we hyperlink all the documents? And he did. And he founded a company, Mosaic, who created the first browser. And that went viral because it was open, because it was easy to scale, because it was fail-safe with a 404 error code. It was such a simple idea, but it made the whole thing work. So it was really genius. And here's the picture, which I took from the website. I have a similar picture because I was in London, of course, looking at Tim's computer. And the nice little sign is, do not touch this. This is a server. So at that point of time, you could have shut down the internet and the World Wide Web with just one press of a button. Of course, nowadays, this isn't feasible any longer. Then, 11 years later, in 2001, Wikipedia, the free internet encyclopedia, was founded. And here, for the first time, you could say, well, this is a tangible asset representing human mankind knowledge. But it was not yet in first-order logic. So it was human readable, it was text, natural language. It started, of course, with English, and this is still the predominant language used for most of the Wikipedia sites, but it evolved dramatically. In over 300 languages, there exist articles on Wikipedia. So it has been a huge success. Also, it disrupted, of course, the business of of some companies who produced these thick encyclopedia, which I also had as a child. I could have had an accident if these books would have fallen on my head. But nowadays, of course, it's a digital platform. And then 11 years later, in 2012, Wikidata was founded. And Wikidata, as of now, contains over 180 million multilingual data items. And this is quite close to first-order logic. It's not complete first-order logic, but it is machine representable facts. And those facts are independent of language. So therefore, this is a rich knowledge source, which is understandable for us humans, but also for machines. And this is the base for metadata, because we need metadata to explain what data is about. And here we have a very rich, free, open resource standardizing metadata. So this is a great achievement. And remember, these knowledge graphs, maybe Wikidata is the biggest open and freely accessible knowledge graphs. But these knowledge graphs are now everywhere. All the big companies, Google, Facebook, you name it, all of them have huge knowledge graphs inside their company. And they use it to link their different databases and knowledge bases to each other. And we as researchers, we can use Wikidata to do that. And I think this is a great achievement. And the cool thing here is it's meaningful to us as human beings. We can read it, we can understand it. We understand what an apple is. We now have a representation of an apple as image, as sound, as text in over 300 languages. So we can use this representation, and it links at the same time into the digital world. So also AI algorithms are capable of using the concept of an apple there. They understanding is such a difficult word in this context, but somehow they understand the context of Apple. They can use it and reuse it for learning, for example. So taking these two driving forces, well, people in Germany and in many places elsewhere thought it's a very good idea to provide a common platform and to provide better access to research data, because we will need it desperately to solve the next problems just in front of us. And here's the big picture: to be able to conduct better research. That is our ultimate goal. Better research. And better research also means faster research results. And how can we do that? We want to build a house that is really stable, and we need a number of pillars. The first pillar, of course, it's us. It's the people. And there's different roles that we have. It's scientists, it's infrastructure staff, and it's data stewards becoming increasingly important. So here we have the people. Second, we have data and metadata. We have tons of data, and we have metadata like Wikidata, but also other metadata schemes coming from the individual disciplines. And now this is the second pillar for this house. And the third one, of course, it's infrastructure. It's compute and storage, the sheer power of HPC and all related artifacts. And our mission is to bring all these bits and pieces together. Now there's still one hole. And I'm very glad you named it, because here we have processes, standards, tools, ethical and legal frameworks, policy frameworks. They all are needed to glue this together. And in a nutshell, what we do is we link the people, we link the data, we link the infrastructure, and we link all this together, step by step. So it's not just one shot and everything works out nicely, but rather step by step, we identify the next step and we try to go the next step. And sometimes it's a very small step, but sometimes it's also a big step. But we need to do it. And actually, NFDI, what I'm representing, is very much on the left and the middle side. So it's about metadata schema and harmonization of metadata schema. It's about services who grant access to data. It's about competencies needed and skills needed. So it's also about education. And it's bringing together the right people. But of course, we rely also on the technical infrastructure. But this is not part of our network. We have a separate network there. And increasingly, we now start to interact and make this as seamless as possible. To answer questions like, I have this very cool, very big data set, which I have in my place here, but the computing is somewhere else. So how can I transfer this now instantaneously? And we ask questions like, we had this joke yesterday at the dinner. So how big is the data? Oh, it's really huge. If I hear this answer, I know it's no problem. Sometimes it's, so recently it was legal people and I said, so what is your data? Oh, it's 10,000s of documents. I said, documents. Okay, consider solved. But of course, then there's these other people and they say, well, yeah, it might be a problem. And then I know I'm in trouble. So we have these 5 petabytes here. Okay, yeah, bandwidth might be a bit an issue here. And we bring together all of these different questions and all of the different people asking these questions, but also all the people who are capable of solving these. It all started with a paper in 2016 by the Council of Research Infrastructures, der Rat für Informationsinfrastrukturen. It was a new council at that point of time, and he created a paper which has been called Power from Diversity. And it was really embracing the diversity of science infrastructure, all the bits and pieces from the previous picture. And this is there. But we need to make this more powerful. How can we achieve this? And that was really the starting point. 2 years later, we got the political decision to get funding in 2018. Then this initiative started. My job started in 2020. So there was a pre-phase. And then since March 2020, my team and I and this whole network are now going step by step. What is the funding about? Well, it's about building up a network information infrastructure. It's really about an infrastructure in the classical sense with a focus on data. It's about establishing standardized processes for research data. I will have one example for a standardization effort that already has been successful. We want to develop a sustainable portfolio of services and metadata schema. And we are not yet so good in this portfolio aspect. So this is something where I'm pushing my network harder now because we have to show politics it's worth the money that you are spending. And they ask, where's the standard? Where's the service? And we say, well, we have hundreds of services. This is not what we funded. We want you to be a very understandable infrastructure. So we have to be, communication-wise to improve, but also on the content level, there's big steps to go forward. Also, we are connecting with European platforms, and there the European Open Science Cloud, the so-called EOSC, for us is the place to be. So we are the mandated member for Germany to represent Germany in this endeavor. I always make a little bit fun of it because it's neither European, it's neither open, it's neither about science, and it's not about a cloud infrastructure. However, it's almost there, and it's such a nice acronym. We all got used to it, and it's really gaining traction now. So it's really becoming something. And at the end of the day, we want to strengthen the subsequent reuse of existing data, right? This is where we started from. More and more research data is already there and can be reused. And this is our key mission. Here's the picture from the funding event, and you see how we all stand 1.5 meters from each other. It took place in Hanover. Initially, we wanted to go to Berlin. Of course, you want to start such a network in Berlin. But then 2 days before, the incident curve went crazy in Berlin. So we said, maybe it's not such a good idea, also politically. Let's go to Hanover, which is not so far away. And what you see here is the German federal state and all the 16 German states who were present as the founding members of this association. So those are the funders, and they are also the first members of the association. And by now we grew to over 300 members, and that is science in Germany, all the scientific organizations. We do only have organizational memberships, so we do not have personal memberships. So it's really bringing together all the scientific organizations. Our association has 5 bodies, so it's an association according to German law. Typical stuff, I would say. We have the board, which is mainly the financial and governing board. So this is politics sitting there. Then we have the scientific senate. This is the strategic organ which looks into the future and has strategic power also. And I'm, as a director, am also the by how do you say, qua amt, by appointment as a director, I'm also the chair of the Scientific Senate, together with 12 personal members. Then we have the Consortia Assembly, and this is where these 26 consortia come together. And this is where decisions about standards are being prepared, and then the Scientific Senate adopts these. So this is how it actually works. Have the communities to come together to discuss the future direction, make a proposal, and then the Scientific Senate has the strategic view and then makes decisions and adopts. The directorate is actually what I'm heading. Me and my staff, we are 18 people sitting in Karlsruhe, and we are coordinating this network of, 1,500 people. And part of my gray hair is from having a communication overload once in a while in this network. But it's worth it, so it's a lot of fun too. But it's also a challenge, frankly spoken. Yeah, and then, of course, the members' assembly, where all the organizational members are being part. And here's my slide about this 26 consortia. And you will see in many of the names, you will find NFDI 4. So NFDI for biodiversity, for example. So it's the National Research Data Infrastructure for Biodiversity. And they wrote a grant proposal in which they proposed, first of all, they identified the next big challenge for biodiversity, and they proposed solutions. And they said we need to bring together science and science infrastructure. So in each of these projects, you will find science and science infrastructure on the same level, talking to each other. What are the problems and how can we solve them? And the problems are very diverse, right? So, for example, in culture, let's take NFDI for culture. They have lots of issues with who owns data. So who's authoring data? How can we grant access to actual cultural data? You can do lots of fancy stuff with Bach and Mozart and Beethoven because the licenses are free. But for old stuff that is current, you have this licensing issue. So and we don't have the money to spend on licenses just for doing research with that. So we need to find clever ways on how to do research with current cultural heritage, for example. That is for culture. Now choose one and identify what are the challenges. That is actually what happened in the scientific community in Germany. We onboarded these 26 in 3 waves. So first 7, then 9, then 10. Was it the right order? Probably. So we have these 26. And they were evaluated by the German Research Foundation, DFG, which is the intermediate funding body. So they get the money directly from DFG. So most of the money sits here on this slide. That is where over 90% of the money is sitting, and the second portion is us. And we are being funded directly to coordinate this network. So this is the current structure. I will come back to that a bit later. Then at the base, you will see the base for NFDI. This is really about basic services, and this is about services that are being reused in all different scientific disciplines. To really identify cross-cutting topics, we have so-called sections, and they form like a matrix structure with these consortia. We have the section about metadata, terminologies and provenance, common infrastructures, training and education, ethical, legal and social aspects, and industry engagements. And just to give you some numbers, so usually we have some 100 people who are coming from the network and who work in these sections. The section infrastructure has 10 sub-working groups. So it's some more gray hair here. It's a quite elaborated governance structure that we have here. But some of the other, like ethical, the ELSA section, it's just a section. They don't have subgroups. So they are much more focused here. Then the base consortium, which I highlighted. Right now, we have 9 basic services identified and brought into funding streams, and it's like an innovation pipeline. So first, you have an idea what to do, and then it gets more and more concrete. There are 3 funding stages, and the final stages ramp up for operation. And then the funding ends. This is actually a pretty bad idea, conceptually, and we still have to find out where the money comes from for all these services coming into the final stage. But this is the ultimate goal, and we are on the road, let's say it like this. But it's, I think we will somehow manage to find the money to do that. And I brought you 3 examples. Those are the first 3 ones. And the identity and access management is, of course, where it all begins. You log into systems. And of course, there are already identity and access management systems. Every university has a single sign-on. And even in Germany, some organizations share IAM services, like Helmholtz has in Helmholtz AAI. However, given the German landscape in total, you can still not log in with your Helmholtz ID to a university, or with your university ID to a Leibniz Center, and so on and so forth. In certain conditions, you are able to do that. So, of course, it's more complicated as always, but this is just not true in general. And we want to lower the threshold, so wherever you work, as soon as you are eligible to work with a service from us, you should have direct access. That is the ultimate goal we want to achieve. It is, of course, about technology, but it's much more about policy and getting the right people to do the right stuff so that it finally works, and do the little twinking. You know, if you are into IAM, you know what I'm talking about. Set the metadata right, set the flags right, and so on and so forth. But this is what we are doing now large scale for Germany. Second is PID services. So if you're familiar with the FAIR principles, you know that you need PIDs for your data to identify them. So it's persistent identifiers. Of course, there are systems like DataCite with GUIs and other systems, and we reuse them. We do not reinvent the wheel, but there are multiple systems. So it's not just data science, it's also URNs, for example. And depending on in which community you are, your community has a preference. So what we try to do is we try to bring these together to harmonize this and to streamline the usage and the reusage of PIDs. This is our task here. And last but not least, since terminology schemas are so important, metadata are so important, we are creating a terminology service where people can deposit their metadata schemes so they are fair by itself and then can be reused for all kinds of different data. Now, of course, standardization is such an important topic that one of the very first corporations we established was with the DIN. So that's the German standardization body especially for industry standards, because we want also to reach out into industry. This is still in its infancy, we could say, but yeah, we are improving. So what we do is we identify where do we need to standardize and who are the people and bodies who need to interact to standardize. And I will make a concrete example here. Here's one example from the life sciences. It's coming from the German Human Genome Phenome Archive. It's very close to the Elixir infrastructure, which you, of course, will be aware of. And what they do is they collect huge data about human genome, of course. And what very soon turned out to be like a hindering factor is that if you want to combine health data from clinical studies with locally connected genome data sets, then this is very tricky for many reasons. And if you are part of Elixir, you know many of the reasons very well. And what we could achieve is we standardized certain things in data processing. And of course, this is something where we also learn from the international collaboration with Elixir partners, for example, but also in Germany, a lot of effort has been put into this to standardize this. And this is sometimes very simple things like data protection compliant through a generalized data protection framework and standardized user agreements. Standardized user agreements. One could think, well, how difficult is it just to create one form? Yes, it turned out since we have 16 German states, we had actually 25 of these forms, and each one looked different, and they were incompatible. And if you compared what the people agreed to do on them, you couldn't really find out if the people signed two of them, if they were contradicting each other. So really the way forward was saying, no, look, this is not how it works. We need to standardize across the borders of the German states and across the local GDPR interpretation rules, for example. And this led to a first small little plant, which we hope to grow now by pouring on some water and treat it very nicely. Also, we want to make the data better, becoming more interoperable. And this is, of course, by standardizing the metadata schema, which are being reused then for various purposes. And life sciences are actually already quite good in comparison to some other disciplines. So there are already a number of standards. Sometimes people say, the good thing in standards is you have so many to choose from. So part of the story is also to start talking about which are the ones we are really using and reusing. Now, last but not least, we link to the European space, the EOSC, and EOSC in itself is a large network. So here I brought a picture from one of the General Assemblies. It's over 300 members spread across all Europe. Some of them are mandated members who have who are mandated by their states to be part of it, but there are many more members who are participating, and some are observers. So if you want to find out what this is all about, maybe starting as an observer with your organization is a very good starting point. Then you will be invited to the General Assembly, for example, see what is going on and can link easily to people. Or you invite people like me to give presentations at your at your events. NFDI jointly with EOSC hosted the EOSC Symposium last year in Berlin. And we had this NFDI meets EOSC format where we brought together different working groups from NFDI with working groups from EOSC, because we also wanted to be an integral part of EOSC. And so far, it was mainly me and my team who paved the way so that Germany is represented. But now we are starting more and more to link also into the community so they understand the potential value of a European infrastructure. And maybe this is also for you, for some, in some reason, from some perspective, an interesting part. Okay. Final slide. I brought you some pictures from the event just 3 weeks ago. So we had our 6th official members assembly hosted in Aachen at the RWTH, the big technical university, which was a great event. And this was followed by the second Cónaidhm conference, so the second conference on research data infrastructure. And again, we had about 700 participants, mainly coming from Germany, but with about a percentage rate of 10%, also coming from countries outside of Germany, many of them European, some even out of America and Asia. I think the furthest person came from Japan. So I don't know, but somehow we also reach people outside. The final picture is just my personal fun. So I was cooperating with a professor for chemistry, and she said, "Well, look, we can make a little explosion to kick off the whole event with a blast." And I was like, "Are you serious?" And she said, "Yes, let's make a blast on stage. Wouldn't that be cool for an introduction?" And we did. So this was a little hydrogen-filled balloon, and I was the one kicking the spark into the balloon, so we made poof. It was lots of fun. Yeah, so this gave you a first impression on where we are and the driving forces, why we are where we are. And now my final slide is part 2. What is the future seen from today? We have still funding, so the funding is running up until end of 2028. Which brings a lot of difficulties because these projects were onboarded in 3 rounds. And for example, the 3rd round, if they also get the same duration of funding, it already exceeds 2028. So they have been promised 10 years of funding, but the last years are outside of the currently funded period, which causes a lot of anxiety in the communities. So it was very important to see what is actually the future. And to be able to come to a conclusion, politics actually in the current funding scheme already foresaw that there will be a so-called structural evaluation. And this has been conducted by the German Science and Humanities Council, which is, I just learned when I prepared the slide for this talk, which is the oldest science policy advisory body in Europe. I didn't know that. Okay. But they have a very high reputation in Germany. So if they give a recommendation, usually it's 2 things you need to know. First of them, it's usually kind of blurry. So you can read many things in these recommendations, and so people then afterwards settle it out, and then funding is granted. But the second thing is, if they recommend something, usually this is being funded. So what happened now is they gave a recommendation. To do the recommendation, they interviewed me for 2 hours. Frankly spoken, I felt grilled. I think it was after my PhD defense, one of the most intense discussions I've had in my professional life. And I learned that they did a 360-degree on NFDI. So they invited all different kinds of stakeholders. It was really, they did the job, I have to say. They invited the consortia, the sections, the policy, the politics. They really had it viewed from all angles. And then something happened that is kind of unusual. They gave a recommendation, and their recommendation doesn't leave much room for interpretation. So it's a very strong recommendation. And we're now in a stage where I have a new job. My role as an NFDI director has shifted dramatically with the publishing of this recommendation. Before, I was the advocate of the consortia. I was pushing forwards the building up of the structure, the governance structure, according to our statutes. This was my main job. Now, my main job is, well, intermediating between all stakeholders who are now finding out what the heck will be funded at the end of next year. Because the ultimate goal is by the end of 2026 to have the next political decision on how NFDI is being funded in future. And frankly spoken, parts of my networks disagree with the proposal that the council has made, because the council has made a recommendation. First of all agree that this is pretty cool. It's about institutionalizing NFDI, make it an organization which has a sustained funding. And I mean, when I started right into the pandemic, my job, this was not obvious that we will receive a recommendation for an institutionalization. So from that perspective, it's a great, not from that perspective, it's a great achievement of the network that we have that we got this. Now, and here comes the tricky part. They recommend to strengthen and to centralize the governance part, which means that all of the money should go to our association and then is being fed into the network. by giving a new network structure. And in this structure, the term consortium currently does not occur. And so many people ask themselves, where is our future in this proposal? And the recommendation clearly says, well, you have to streamline your efforts. It's very nice that you have 26 NFDIs in plural, and they all think they are the NFDI. But what is missing is what they all call the one NFDI. They all say we want to be one NFDI. But if you talk to them, it's my NFDI for X. And only with really headaches and lots of great hairs, we get this cross-cutting topics more and more through. So now we are in this really intense phase where we need to align the network because we want to have them on board, of course. I do see a clear future for the whole network, a sustained and institutionalized future, but we have to rebuild our governance structure. And this is a really cool job, I have to say. And I'm very open for discussions and collaborations because this now for us is also a time where we seek out what are the next steps. It will be big steps. And how can we do them together? Because clearly what we have learned in the past 5 years is we're not alone and we cannot solve all the problems by ourselves. And the better we link together all these research infrastructures in Germany, but also beyond, the better we will be able to do to reach our goal, to do better research. So that was my motivational speech. I'm looking forward to many discussions with you. Thank you very much for inviting me.
Hi, Karina Rodriguez from the University of Brighton. I really like how you frame data as this common good and something, for good of science. But I was wondering what type of conversations or insights can you give us with regards to the private infrastructure? So I work a lot with cultural heritage institutions where they interact a lot with private infrastructure, and the relationship is, sometimes it's seen with suspicions, right? Because you just put at the very end this idea of using AI to leverage the data. And I just wonder what conversations or how much you can see threats as well as opportunities with the kinds of Google and Amazon infrastructure. A lot of our institutions probably have access immediately before they go into these publicly funded infrastructures. Thank you.
Yeah, thank you very much. So personally, coming from AI, I have good experiences with working together with companies like Google and the likes. So I have a very neutral view on the whole issue. However, in politics, more and more people are aware that digital sovereignty doesn't come for free. And within science, more and more, digital sovereignty is also linked to we close ourselves a little bit down because we have competitors in China and so on. So we don't want to give away all data for free. And especially in the engineering sciences, we therefore have collaborations between industry and research, which is very close, and where the data is being shared, but in a closed room. So this metaphor of open data and open science there is not as true as in other communities, for example. So depending on which community we're talking about, the answer will be different. That is my first answer. However, we funded the section industry engagement because we are well aware of that. And we know that research as of today, it cannot be done without good and strong links to industry. We would cut ourselves from a lot of funding streams and a lot of interesting data actually also if we would not embrace this opportunity. And this is what we actually pursue. But the answer really differs from community to community what the best approach is there. But in general, maybe in a nutshell, but in general, the aim of politics is that research data should not be given for free to the big tech companies who just harvest data, sometimes in an almost unlegal and unethical manner, right? So we want to have a better control of what happens to the data, but clearly everybody eligible to work with the data should also have access to work with the data under the conditions and terms that are appropriate.